You ended up finishing the async book?
I have like a couple chapters left. I have to
Okay.
go back and finish it.
Yeah.
That is something
I
that I
ended up
want
looking
to
at
do.
chapter 9 for like the pinning stuff. And then beyond that, I was like, nah, the rest I'll read some other day. That's okay.
Can I delete this? How do I delete this from YouTube? Oh, YouTube, I love you so much. Okay, so note to self, you have to click the thing that you want to like go live with. You have to like explicitly click it. All right, but now we're live under the right one. Cool. All right. You guys said you wanted the links, right? So here, Twitch and YouTube links. Get shareable link. All right. Yeah, one of those should go. Perfect. And then if someone wants to like join that stream and make sure that my audio and your audio and everyone's audio is great, let me know, because that would be fantastic. And I can close all these apps.
I
Perfect.
actually already follow you.
That's right, boy. That's what I'm talking about. Yeah.
Wow, you just didn't pay attention. You just ignored everything.
Me or him? I don't know what you're talking about.
I'm talking to Devin P.
I'm
Turn.
really
Okay,
good
I
at
can hear
not
him
paying
on
attention.
Twitch. Whoa, you're streaming stuff that's not nothing. Whoa.
Oh, I have to do the category if on Twitch. What is this? Programming? Is there what category is this? Books? Science and technology it is. Done. All right. Everything should be good for both streams. I guess we can get started. Looks and sounds good. All right, thank you, Aaron. You're the best. I don't really need these two open. Cool. I just need chat. Yeah. Thank you. All right. So we're kind of doing like a speed read of this book, and I've read this book way back in college because it was part of a curriculum, but I read the 4th edition. So yeah, I mean, you all had expressed interest in learning Linux things, and you gave me the table of contents of this book, and I basically said, here's what you should read and here's what you shouldn't read. And that's kind of what we're doing. So we're doing an abridged read of this Unix and Linux Administration Handbook, 5th edition. Today we're going to talk about what, chapters 2, 3, and 4, I think, right?
Yep. I cheated and I read chapter 1 also. Can't believe it.
How dare you? How dare you? So yeah, let's talk about it. So chapter 2, or do you have any questions from chapter 1? We'll just go chapter by chapter. Does this give me like a better...
I feel like I don't have too many questions. There's just a lot of different things that I learned throughout. Like, I like explicitly describing what the syntax for man pages is, like the optional square brackets, things like that. Like, I've been able to look at them and understand it, but just having it, like, knowing that's just a thing is pretty good.
You got that from chapter 1?
Yeah, chapter 1.
Okay, so it basically gave you like how to find docs and all the other stuff. I didn't read chapter 1. I completely skipped it.
Yeah, they had like man page syntax. Like, you probably like search that.
Okay. Cool. Yeah.
That book looks way better. I'm reading it on O'Reilly, and it does not look as nice as this PDF.
Oh, is the one I'm streaming?
Yeah.
Yeah,
I just, like, inserts images into the side.
Gotcha. I ordered the physical copy. It wasn't here yet, so I have this PDF that I'll use anyway. I don't even know what legalities or anything are of streaming PDFs, but whatever. Life is life, right? Okay, so you learned about man pages, you learned about all that stuff. I didn't read chapter 1.
Right there.
Any?
15. Yeah, chapter 15. But
You mean chapter 15 or page 15?
oh, it's on page 15. If you were looking for it, I wasn't sure if
Oh
you
yeah,
were.
yeah. No, this is a very helpful thing. There's a lot of ways to get help in
Oh yeah, that
Linux.
looks nice in
Oh
there.
yeah, you should use
And
this PDF
the
then, man.
O'Reilly version, it takes a nice picture of the like the shell there, and it just sticks it in there. And it looks weird,
Oh,
but
like
here
this
it just
shell?
all looks nice. Yeah, like that. Is that text? Wow, it's not even text. Is that table text?
I
Like the
think you need to
table
use the
above?
PDF instead of O'Reilly.
I don't have access to that though. I have the O'Reilly through work, and I read it there.
Oh, gotcha. Okay, you're a better person than
Is
I am at this point then. But yeah, no, man pages are extremely powerful and they're really nice. I don't know, like, did you like use them for anything? Sure. I use them like
I've
all the
used them
time.
before, but typically I just grep through help menus.
Yeah.
Or
I
like
think
in here, and I can like control command F, find stuff.
yeah, you can do that. And there's like other help things you can do here. I haven't like used the help part of the man pages because there's like key bindings you can use to like go through different patterns or different sections of it. I don't really know. I just grep. I just like search along the man pages for examples and what I need to do. But I remember like before I even like knew how to use man pages, a lot of commands have like key scan dash dash like that. They have dash dash help usually. I mean, this one doesn't, but whatever. And usually there's other ways to get help. What kind of bothers me though about man and all these other things is they require like the man pages to be installed on your machine. So they don't just come for free with the commands. They have to actually like be installed for you to like use them. And that kind of bites you in the ass when you're trying to debug things or whatever on like containers or some other place where the man pages usually aren't installed because it's a production container and for size constraints they don't install it. But just wanted to let you know in case you didn't know.
Yeah, I mean it
So,
goes into like where it's stored. Oh, go ahead. Sorry.
and then I was gonna ask, like, whenever you install a program, does the man page gets installed along with it, or like it's like another thing entirely that gets installed? Like, is there a directory for man pages for everything that gets installed in your system?
Yeah, I think
I
it's
think so.
user share. Yeah, user share man is where man pages are usually stored. You can also store like local man pages for your local user, in like user local
Yeah.
man or whatever, user local share man. But to answer your first question, it depends. Most of the time when you install a program, the man pages and documentation come with it because the package manager or like the person that packaged that program up for you for your operating system put it all in there.
Mm,
You know what I mean? So like when you install a program, you're not just getting like, if you do like apt get install foo or DNF install bar or whatever your package manager is, you're not just getting like
yeah,
a single binary there. You're getting like an archive of different files that are going to be installed in different locations on your system. One of those paths are going to be the binary for you to actually use the command. And another thing might be the man pages, and another thing might be like a default configuration file, and so on and so forth. So you're just getting like a whole archive of things.
got it.
And from what I can tell, you can install your man pages wherever you want
Yeah.
because it doesn't specify, but it's better practice to put them with the other man pages, and that can be also changed through environment variables if you'd like.
Did they cover ManPath? Yeah, they did. Okay. Okay, they covered
They
ManPath.
go into that's where I know all this stuff from. I read the pages.
Nice. Yeah, I didn't read chapter 1, but ManPath is funny because when I interviewed at Apple, they asked me a question about ManPath, and they were like, "Hey, if you set your ManPath to this value and you run man this, what happens?" And really, the answer was like a fork bomb happens because ManPath like evaluates itself, and they like did like a recursive fork bomb that would like hang in the terminal and stuff or crash the machine. So yeah, that was like one of the earliest. That was like one of the only times in the field I've ever heard of someone even touching ManPath. Someone in the YouTube chat is saying, or Aaron in the YouTube chat is saying, that usually if you use the official package manager, it's almost guaranteed to have man pages for whatever you're installing. Anything else from chapter 1, Jacob, that you want to, or Dev?
I actually didn't read chapter 1.
Okay. Well, then it's Jacob's journey here.
Yeah, so other things for that. I thought it was kind of cool that there were, like, that just nobody knows what B for byte, or like B is for bit, B is for byte, but the other capitalization is like whatever. Nobody knows. So I thought that was cool just to know that literally nobody knows.
Oh, like the units?
Yeah, like the units don't matter, like, and then
Where
like
do they talk about
megabytes,
that?
whatever, can be different.
Was there a page
But
that
yeah,
they
I
had
thought
that?
there's like, I'm not sure. It gets into it with like they talk about like the Ubuntu, like has a specific way to go about it.
Oh, okay.
But,
Yeah.
yeah. Someone after the man page, but I thought it was cool because it's just like nobody knows. It's not just like I didn't memorize them correctly. There's don't exist.
Yep, that's pretty much like the answer to most standards and stuff in the whole technology field. It's like nobody really agrees or knows what's going on, so everyone just does their own thing. I'm trying to skim the rest of the chapter. This PDF doesn't have like I don't get like a do I get like a better. This is better. Okay. I wanted like a breakdown of the chapter and now I figured out how to get it. Anything else that you want to talk about from chapter 1?
I was wondering, like they talk about like you should not when you're doing a web installer, you should not pipe to like sh or shell. Do you just say bash for sh? I feel like yeah.
Well, sh is not technically bash. Sh on most systems is going to be like a symbolic link that points to whatever default shell the system has installed. So like /bin/sh usually symlinks to the bash shell, but it could symlink to another shell, or it could be its own shell, like the Bourne shell. So it's not always like bash, but generally nowadays it usually is bash. Like that's like the common shell you will find.
Oh, that's good to know.
And you
What
can
is
change
the
that there.
.sh, the bash syntax, like what that's called.
Kind of, yeah. So sh is called the Bourne shell, and then bash is called the born again shell. So that's why it's like called bash born again shell.
And the sh is what again? Sorry.
Just shell, yeah.
Oh.
What's ZSH? ZSH?
Yeah. ZSH, GSH, that is the Z shell, they call it, I think, right? I don't even know what the proper name of it is. I think it's just called the Z shell, right? I don't even use ZSH, so I don't know if it has a different name. Yeah, Wikipedia is saying that it is the Z shell. That's what the name of it is. But there are many, many like different shell programs that you can use on your machine. You know, Bourne shell, Bash, Z shell, Fish, like the K shell. You can use so many different shells on your system. But Bash, Z shell, and Fish is they're like really the popular ones out there. ZSH baby. I think macOS switched to ZSH.
Yeah. The other thing that I was wondering about that, like they say it's somewhat like they're thinking about it being somewhat superstitious to do, but like don't pipe to sh, don't pipe to shell, because it could fail and give you a partial script.
Yeah. So when you do like, I don't know, let me change the template directory. So when you do like curl, you know, https foo.com or something, or example.com, and you like there's something there and you pipe it to your shell to like to run whatever script is there, you might not be getting the complete script, right? Like because your http requests It might not be complete. Something can happen, give you bad data on your input stream, and now you're piping that bad data straight into your shell, and that's like not great. But so many websites, they have a one-line installer of like, hey, just run this curl pipe to bash script and you'll have foo application installed. Everything will be happy. But yeah, that's generally not a good thing to do unless you like don't care about the risk or completely trust the site that you're going to. Instead, you should just download the script yourself and then run it through your shell after you like gave it a once over or something.
Okay, I'll be back.
Yeah. You have to go do work things.
Mm-hmm.
All right, we'll be here. All right, so Dev, you read chapter 2, right?
I read like 10 pages of chapter 2.
Okay. Do you have any questions on chapter 2?
Oh, not so far actually.
I can just like give it a once over, and then if you have questions, we can answer them there.
I didn't get to try much of the stuff actually. I just like gave it like a quick reading basically.
Okay. Oh, sorry. I didn't mean to click that. So chapter 2 was all about booting and stuff. So this was a fun chapter. I already like knew most of these things, but it was good to read it anyway. But chapter 2 was all about how a machine boots. And remember, like we're thinking about these things from the Unix Linux perspective, right? So we're not really talking about like Windows or something else. We're just kind of talking about Linux, Unix.
Yeah.
And they basically give like the overview, you know, when you press the power button, something's going to happen and it's going to eventually load a bootloader. And that bootloader is going to actually find your Linux kernel and run the Linux kernel. And then your Linux kernel is going to execute its first process and start up the rest of the system. And then the rest of the system is going to just like, you know, maintain those processes and manage them. So that's kind of like the whole idea. I think the image that they have at the top of this chapter is actually pretty nice because it, you know, it's hurting animals and, you know, hurting, not hurting. That's a hard word to say over stream. It is hurting animals and like guiding them somewhere the same way your system, you know, process 1 herds and manages processes for the whole system. Yeah, go ahead.
No, it's like, you know, the init process starts everything. And so I know about the system D stuff. I mean, I don't know about system D. All I know is about like, you know, what they did and everything, which is like different from Unix. But that's like my prior knowledge, not right, you know, not from this chapter. So do you know what's the difference between those two are, like systemd and like init?
The book tries to go into like some of that where they talk about, where do they put that here? Systemd versus the world, essentially. So the book talks about systemd and init. So init was an earlier process, you know, management service, essentially, like the first process that runs to boot up Linux. That was called init. And I think that came from Sys5. I don't remember off the top of my head. I don't remember exactly where it came from, but it was a very popular way to basically boot up your Linux install, right? You run the init process. The init process runs all these like other init scripts and they start up other processes, and like that's how your system kind of boots and it gets managed. That all went away like what, 10 years ago now? I don't want to say went away, but like systemd came on the scene like what, 10 years ish ago, and systemd was like, oh, we're gonna do more than just manage the init processes. We're gonna manage like more things in your system. And people got mad. They were like, no, Linux is supposed to be very simple and one, you know, do one thing and do it well, why are you muddying the
Yeah.
water with system D? And like, I don't know. I don't really have any skin in that game. I don't really care as long as my system boots and I know how to like configure like how it boots. I don't care if it's Init or
Okay.
system
Okay.
D under the hood. But most Linux machines that you're going to run nowadays, it's going to be system D under there. Unless you're running it in Docker, then you're going to like, have a different
Yeah.
init
Like
process essentially.
I think Alpine doesn't have like systemd in it. It's like init.
Right.
Yeah.
So that's kind of like where the init and systemd stuff comes. Did you understand the like, or have you heard of like BIOS and UEFI before?
I've heard about BIOS, but you can definitely tell me more about like UEFI.
Okay. Yeah. So basically, much like init, I don't know why. Oh, that's too. I guess that's better. Much like the whole init versus systemd thing, there's like a BIOS versus UEFI thing. So BIOS was the traditional way of how PC firmware kind of started the system, and that stands for like basic input output system. And its responsibility is to, power on the components, test them, make sure they're okay, and then like start the first instruction to like load the bootloader, right? That's what the BIOS and UEFI, that's what the responsibility is. I don't work at this level of the stack, so again, I don't have like skin in this game. All I really know is that UEFI came on the scene and was like, BIOS is old and outdated, and it works in this weird way. UEFI is going to solve all our problems, and there's many people that are like, great, I don't care, just boot my machine. And then there's also many people that are like, UEFI is a nightmare and it's a mess. I don't want this anymore. So I don't like work much in here. All I know is, at work we have to boot machines ourselves, and we like use UEFI boot because that's like the popular boot. That's like the popular way of doing system firmware nowadays. But I don't know much about like how it's implemented and whatnot.
Okay. What's the program like EFI boot like manager, I believe, because I did try to run it. It didn't like.
Oh, if you don't have EFI boot manager, you probably don't have EFI boot on your machine. My machine that I'm on right now does boot using EFI, so I do have the EFI boot manager command, and I can see like my boot variables and all this other crap. I was actually, when I ran this command before, I was like, kind of shocked to see this Windows boot manager entry here. But then I remembered I pulled the hard drive out of my Windows machine and put it over into my Linux machine, and I installed Linux on that. And I don't think I wiped the hard drive like completely to zeroed, so maybe that's why that's still hanging around. I should probably get rid of that at some point. But yeah, I boot using UEFI, and I can run these UEFI, commands that the book is showing us. And you can see like at /EFI, I think it's actually /boot EFI. There's, place your finger. There's like an EFI directory where I have all my stuff for EFI. Oh yeah, I can't share in Discord for some reason because I'm on Linux and I'm in a browser talking to you here.
It's alright. It's okay. I can see your stream.
Yeah. So I think that's where my boot EFI all is. I think there might be some in other locations, but I forget. But yeah, basically two different ways of running firmware for your machine: BIOS or EFI, and EFI is like the new way. And I don't know what I just did to make this book go crazy just now. I guess I clicked something wrong.
So what window manager are you running?
This is just GNOME. GNOME, GNOME, whatever, however you want to call it.
Okay.
GNOME.
GNOME.
No, I don't know. GNOME, I guess, is how the proper way to say it. All right. let's I guess move up to bootloaders then. So after like your BIOS or EFI firmware runs and does its thing, then it's going to start a bootloader to make sure your system can boot. There's not really a lot of magic here. Technically, one of the benefits of EFI over BIOS is that you don't need a bootloader with EFI. You can just load the OS directly, and like some Linux installations do that. They just use EFI boot or whatever it's called, and they boot directly into your Linux kernel, and you don't need a bootloader, and that's cool. But generally speaking, most Linux machines that you're going to run, they run a bootloader, and the bootloader is usually going to be called Grub or Grand Unified Bootloader. And like that, just, the Grub bootloader is responsible for, hey, how do I load the Linux kernel? Like that's its sole job, is to find the Linux kernel and load it.
I can try it. I feel like since you're like so experienced, I can just ask you directly. So if I download the EFI manager stuff, it's not like EFI boot manager stuff. It's not going to like clash with anything that I already have on the machine. That's like loading the thing with like Grub, right?
Right. Yeah. So if you just download the programs and you want to run them on your machine, like if you wanted to download EFI boot manager, it's not going to actually modify anything unless you run a command to modify something. But just the act of downloading it and installing it won't do anything, because your EFI firmware image essentially is on a disk somewhere in your machine, and your machine knows how to like boot to that. Like it knows how to load that EFI firmware. So if you don't do anything to mess that up, then you're good.
Okay. Because sometimes it's like, you have like the Grub installed in some other space, and if you like get rid of that, I'm not sure. Again, this is like coming from very
I get
super,
you.
So that messes things up as far as I know. So that's why I was asking, like, if I do the EFI boot stuff, is it going to like take over or like clash with something that's like starts up whenever Linux starts up?
Yeah. If you just install commands to like poke around, you'll be fine. The only time you'll hurt yourself is if you like actually configure EFI on top of your like BIOS or whatever that you're doing and like clash that. But it doesn't sound like that's what you're gonna do.
Okay, got it.
And like if I like removed all the files from my hard drive and like did like an rm-rf and removed like everything from /boot or whatever, then I would be removing my EFI firmware and my bootloader. I'd be removing those things, and then my system would not be able to boot anymore.
Okay. Got it.
Get you a VM. Yeah, that's a good idea. So Aaron in chat is saying you can like test. You can create a VM, a virtual machine, and test all this stuff out in there if you want, and like do whatever the heck you want with it, because it doesn't matter.
Yeah, I mean that's what I'm going to do actually. I basically, get 2-3 versions of Ubuntu and try if I can like mess those up like while going through this book.
No, that's a good thing. I always recommend people to do an install of Arch Linux. Like I always recommend this to people that are interested in understanding how things work a little bit better. And yes, there's people out there that are going to be like, Arch Linux is not the be all end all of Linux. Oh my god. But if you run through the Arch installation guide, you'll get a pretty good idea of like the different components, right? The actual like firmware, the bootloader, the kernel itself, packages. You'll get a good good overview of it. So I recommend people like try it once.
And ironically, I actually do think Arch is like pretty good to start with because of just the amount of documentation available out there for Arch.
The Arch documentation is the best, right? The Arch wiki is just like the best documentation that's out there for the most part. It's really good.
Yeah.
I'm on Fedora, and I often go to the Arch wiki for like just to solve problems that I have with Fedora or whatever.
Yep. Same. It, like you find answers there that you don't find anywhere else.
Yeah, exactly. Someone saying that the folks at Oxide did a podcast episode about the challenges they had to boot using BIOS or UEFI. Ooh, what's the link to that? What's the link to that? episode. I gotta go back and watch it. All right, so let's also hello, homie. I saw that you joined the Discord, so what's up, dude? I don't know if you're lurking. Oh, I see you.
You hear me? Yeah, I'm just gonna be listening. I'm pretty sick, so I'm just gonna not talk much
All right.
for this.
Well, you could always type if you have, just mention me if you have like a question that you want to get out.
Yeah, I'll send it in the chat.
All right. Cool. All right. So moving out of firmware and bootloaders, at some point your bootloader is going to load the Linux kernel, and the Linux kernel is going to say, hey, I want to start up and load my init process, right? Either systemd or init or whatever. And then that's going to start. Any questions before we kind of go into somewhat about systemd and whatnot? I also see why streamers need multiple screens, because you need multiple screens in order to stream. There's so much to look at. All right, cool. Interrupt me if there's any questions. So your Linux kernel boots. It starts systemd. Systemd starts up, and it's like, hey, I got to start this machine. Let me load a bunch of other services and run them, and do that thing. Now, I think it was in this section. Let me just see if I can find it. I forgot to note down the page, but there was a part in this section about how like processes kind of work. I'm gonna see if I can. It could have been this in the next section. Either way. Anyway, systemd has a concept of what's called like unit files, and a unit file is basically just a description of what process to run and how to run that process. And there's many unit files on your machine, and systemd runs them in various different orders, and effectively you'll have like a big process tree where like the first systemd process 1 is running, and all the other processes that are running on your machine run as child processes underneath that process. And you have like a tree essentially. And that's what that looks like. If you want to like manage any of those processes that are running via systemd, get all them screens. Yeah, I probably need another screen. Right now I have laptop screen and desktop screen. If you want to manage those systemd services that are running, you can use the systemctl command. So this is a command that's pretty safe to run on your machine if you're following along with your own machine. You can run systemctl with no arguments, and you will be put into like a pager to see the different like units and stuff on your machine. And if you want to like start and stop different services, you will also use systemctl, right? Systemctl start, systemctl stop, systemctl enable, disable, blah, 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 blah. And the book lists the common like subcommands that you'll use when working with systemd. I used to like use systemd all the time in previous jobs because I was like setting up services and making sure they run on boot and blah, blah, blah. This was like before containers were a popular thing. So I used to be very good at systemd stuff and understand its intricacies. And now not so much anymore. I have to like reference if I need to do anything pretty wild. Like, don't ask me the difference between systemd like service types, like one shot, forking, or whatever. I don't remember. I don't even care. I don't care. I'm checking the other chat too while I look. Cool. I think that's pretty much it about systemd. There's not really much else to describe here except for the fact, maybe there's one more thing. If you're asking yourself the question of like, how the heck does systemd boot into like how does systemd know to boot in a certain mode? Systemd has this concept called targets, which is basically a collection of all units under a thing called a target. So when your system boots by default, it boots into what's called the multi-user target, right? Like if you're on your Linux machine, right? You're on your Ubuntu machine or whatever, your Fedora machine, you can log in with your own user. But if you had a separate user account, you could also log in with that user account too. And both of you can be logged into the machine at the same time and share the system. That's the multi-user target. That's like the default target that Linux boots into. There's also other targets like a rescue target, a single user target, some other targets I forget. And those allow you to boot the system kind of like in quote unquote safe mode if you need to like do any repairs or whatnot to the system.
I'm back.
What up, dude? We covered system firmware like BIOS, UEFI. We covered bootloaders. And now we're kind of talking about system D. Do you have any questions in chapter 2?
I just thought it was like I had heard System D a lot, and then I knew that like WSL didn't support it for a decent amount of time, and like it's there now. But it's cool
nice
to know that like what it is pretty much.
Yeah.
I'll be on the Discord one. So yeah.
Okay. Yeah, we're here.
If that's okay. Yeah.
Yeah, we're here. Joe from like a YouTube chat is saying that targets replaced an earlier boot concept called run levels. For compatibility, you'll also see like a target called a run level N, where N is like a number. Oh, this is true. I remember running to someone's machine and running like init 0 or init something, and you can just boot into the run level, or like, you know, do a shutdown run level, a reboot run level. I remember those days. Fun times. But yes, System D's targets are the equivalent of init's run levels. Any questions, Jacob, on chapter 2?
I guess I'll go back and hear what you had to say about the rest of it, but
okay. Yeah.
I feel like I don't have too much. Like a lot of it's just like higher level information or like lower level actually. So I got like the high level concepts of what things were.
Right.
But I don't think I'll need to necessarily know all of this stuff. I like messed around in my like console and did like system control and found some stuff and looked around, but
yeah, the only thing you'll probably need to do is like restart a service or something. Maybe that's like the only thing you would need to do.
Oh, okay, yeah, like I checked it and I found a failed. Yeah, I guess that's a good question to ask. Like I opened it up and I found a failed service and I tried to restart it and it said to look at the logs more.
Oh yeah.
And I don't know what are the implications of the failed service? Probably depends on the service, right?
That's a good thing to talk about real quick. So systemd like services, if you like do systemctl, I don't know, status sshd or something, that's me getting I don't have SSH running on this machine because it's like a desktop. I don't really SSH into it, but I'm getting the status of this SSH service. And if I wanted to like start that service, I can run start. It's going to ask me for authentication because you need to do that as root. And now if I run status again, I can see like all the information about that service that started. I can see its process ID. I can see its whole like process hierarchy. I can see the last n number of lines of logs from that service. I can see where it loaded the systemd configuration from. And there's like two sections of configuration that you can use. There's like the default configuration that gets shipped with a program, and that's under user lib. And there's also like a user override location at like etc. So if you didn't like the default systemd unit file that's shipped with a program, you can override it by like copying it to a location in etc and changing it. So like there's a lot of service.
What would be a reason that I wouldn't want to do that? Or like what would be a reason that I would not like the unit file shipped with it?
Like you can patch it, right? Maybe there's like something that was wrong with it that it has not been released in your package manager, but you need to like fix it live. So you can patch the configuration. You might need to extend the configuration or change it, adding new environment variables or whatever. So that those are good reasons to like use your own override files. Not super common, but those are reasons you can do it. And if you're creating your own custom services that like don't ship with the system, you'd put those all in Etsy, right? So if you created like some new foo service, you can like create a systemd unit file for that foo service in like Etsy systemd system foo.service, and then boom, now you have access to running that service with systemd. But we were talking about logging real quick. So generally, I'll like be I'll do the hand waves in front of the camera. Generally, a systemd service uses like logs to standard out or standard error, and systemd captures the standard out and standard error streams and exposes them via journal D, right? Which is the system's journaling daemon. And then you can read those logs using journalctl. So for you, if you needed to read those logs for that service you were talking about that failed, you would do like journalctl and then like -t for target or whatever, and point it at the service you wanted to get the logs for.
I thought I was looking at it. I put
-u.
The stack. I guess it's not a stack trace, but I put the log in the chat here. Like
in the voice chat?
Discord one. Yeah.
Oh, yeah.
So, like, I was just like, I don't know. Like, my thing seems to work fine, but I really don't know. But yeah, it would be good to, like, know what this kind of stuff means.
Yeah, so those, like, log lines that you see at the end there. So you see, let me copy this out to a text editor.
Yeah, that sounds good.
I'm taking your logs forever.
Can't believe it. All of my sensitive information.
Yep, that's it. It's done. I got it. It's all done. So in this case, you did like systemctl status systemd remount fs service. So this is like a service that I guess runs like knows how to mount file systems or whatever. I don't actually know what this service really does under the hood. And you're seeing that it failed and it like exited, and you can see, you know, all of your logs here that show like these are the last 5 log lines that occurred that systemd captured. And it notes at the bottom like, hey, the journal was rotated since the unit was started, so you might not have all the logs. If you wanted to get more logs for this service, you could use journalctl with like -u for unit and give it this unit file name, and then you should be able to get more logs there and then understand what happened with the process. But it looks like, you know, this might be the error that happened here because it couldn't find a label or something. I don't know what's actually happening here, but this is how you can find more information.
Yeah, I could probably look into it. I need to look into the service and know how important it is and everything. And probably a restart couldn't hurt see if it comes back.
Let me see if I even have this service.
Like any
Oops. So sorry, I clicked the wrong button and it made me like leave Discord. I just clicked the wrong button. Yeah, so my service is active.
See all the lag or like the latency between the stream and this, because I can like see you're like, I'm gonna wave my hands, so like 3 seconds later you wave your hands.
That's funny. I think we're probably on a 6-second delay from stream. I can't stream my screen actively to Discord to give you like live stuff because I'm in a browser and it's like not letting me do it correctly. So
yeah, it's fine enough. It'll just be like if I try to give you instructions to point at something, I'll just like be like, no, you're not pointing at it yet.
Yeah, I get you. Joe from YouTube comments are saying that you can also use journalctl to view logs from a different boot. So if you did like -b2, you can boot from like the second boot, you know, the second to last boot. And sorry, that's -b-2. I didn't know that at all, which is really nice to see. But yeah, journalctl is like really powerful and integrates pretty well with systemd. I recommend people to like play with it and look at its help stuff. I didn't know that. That's so good. Wow. So many things you learn just by talking to people. And he says it's very nice for things that cause kernel panics because then your machine's going down and you don't have the logs live anymore. Omi's asking in Discord from a separate boot option. No, from like the previous boot. You know how like, you know, my machine has been up for what, 7 hours and 5 minutes or whatever this is, I think. If I rebooted my machine, all the logs start fresh again. But if I wanted to see the logs from the previous boot, I can use that like -B option to see the previous boot. Right? This means 7 hours and 5 minutes, right? I think. That sounds right. That sounds about how long I had this machine on today. Time. What is time?
Yeah, but I guess my general questions about all of this is just like how useful is all of this stuff, because I've never really interacted with this as a casual desktop Linux user,
Yeah.
and I've never really, I've never had to really, I guess,
You're
know what any of this is.
Yeah, you're often not going to have to interact with systemctl or journalctl on your like desktop workstation Linux machine, right? Because you're just using that machine, you're coding, you're doing whatever you are, and like you're just using the machine. If you're managing Linux servers that are like serving things to other clients and they're running their services, you know, using systemd or whatever, then you'll probably have to interact with systemd and journalctl, right? But even then, nowadays, a lot of people deploy their machines in the cloud, and like there's automatic processes to like ship those logs somewhere else, you know, to like Datadog or wherever. So maybe you don't ever have to go to the machine to like manage processes or like get logs, right? Maybe you just get them for free. But it's still good to know, because at the end of the day, like even that magical stuff that cloud providers and stuff give you is powered by things like this under the hood, you know. Omi asked, how often do people interact with the EFI boot manager? Not often, unless things go wrong, right? Like when you install your machine for the first time and you install Linux on the machine or whatever, you install your BIOS or EFI firmware, then you install your bootloader, and then you like never touch it again, unless something breaks. So not often. Joe's also saying in the comments on YouTube that systemctl and journalctl are also very useful tools when you're interacting with like a support staff and they want you to get extra debug information before they like help you, or if you need to file an issue on GitHub, you'll often have to dive into journalctl or systemctl to get logs. Okay. Any other questions from this chapter 2? I take silence as the best answer.
Yeah, I don't think so. I'm just thinking like, is there anything? But then, like you're mentioning, like a lot of the stuff, like Linux-y based, is not things that I have dealt with, because like you either ship things to the cloud or I don't know, there's just some logs folder for whatever application I'm looking at. But to be fair, I didn't really know any of this stuff in the first place to be able to look it up if I needed to.
Yeah, I get you.
Yeah, so can you give another example of when I would need to look at any of these like daemons or anything?
The prime example for using like systemd or systemctl to interact with like services and such is your machine is running a service that you care about, right? Like if you installed Nginx on your machine and you want to start Nginx, you'll do systemctl start Nginx, or you'll do like enable Nginx to start it on boot and all that. And then like something happens and Nginx process dies, you would use systemctl status Nginx to figure out like what's going on, where are my logs, what happened. That's like a common thing. Again, in modern infrastructure providers, a lot of this stuff is like, I'll just run Nginx in a container, so I don't care. But even so, under the hood, containers are just processes that you still can see with a process manager. So there's going to be times where you have to use systemctl.
When I ran I ran the Minecraft server for some time, and I just used, I don't know exactly how you say it, but like no HUP, like no hang up.
Yeah.
I used that to just run the thing whenever my shell was closed, even so. And then for that, I just used like PS to look for it if I needed to.
Oh yeah. I've done that before too, where I use like screen or tmux to like SSH into a server, and then open a screen or tmux session, run a process, and then like detach from that session and then leave. That's like the poor man's service manager. That's perfectly fine, honestly. Nobody's gonna bother you if you do that. But if you're gonna run more production level stuff, you might want to like create your own systemd unit file for it. That's why so many.
Okay.
Yeah, that's when you would want to use it, and that's why so many programs like Nginx is a great example. When you install Nginx on your Linux machine, you get not only Nginx the binary and all its libraries and such, you get a systemd unit file to start and stop Nginx, and that's how you manage it.
Yeah, that makes sense. That wasn't the worst mistake I made with the Minecraft server. That was allowing anyone to access it to they could find the IP.
I think a lot of people sleep on how simple it is to actually get a service up and running with systemd, and you often don't need the complexity that like some container management solution comes with. You can just like, if you just have one binary to serve to someone and you want to run that as a service, just make a systemd unit for it, set it to start on boot, and like you're chilling. You get log rotation for free, you get like management for free, you get a lot of stuff for free when you do that.
So in this case, is systemd also like, this is what I had thought systemd was kind of like a scheduler, but I mean that's somewhat what this is. But is it like Windows has a startup folder and it runs a bunch of executables or things you have in that folder? Is it similar to that?
Yep, that's essentially what systemd is doing under the hood. It has what's called like different targets, and different targets are like what you boot into. So you want to boot into like the multi-user target. In that target, there's many systemd unit files that when you boot into that target, it starts automatically on boot. So like for like the Windows comparison, yeah, it's kind of like that scheduled process to like startup processes on boot. That's kind of a good way to do it for a Linux server. If you're running like a desktop version of Linux with like a GUI, there's also like a startup program thing in your like desktop environment that you can also use. But that's what you would use to like launch, programs at startup, like Discord or something. You wouldn't use that to run a service, So like similar concept, but different. And systemd also has the ability to like run services based on like certain events that happened. So like if you mount a drive, a systemd unit can fire. If you like open a socket, systemd units can fire. If you wanted to do like a time-based thing, you can do timers in systemd where systemd units can fire and all that stuff. So like systemd is pretty powerful.
How does that relate to something like cron tab then?
It's essentially like a replacement for cron tab, or at least it's trying to be. You could do
I just did not know that system what it was to find that out.
Yeah. I don't know how common systemd timers are in comparison to just using cron. But it's a thing that you can use, right? There's probably someone out there that says no, cron forever, and there's probably someone out there that says no, cron's dead, use timers. And there's someone probably else out there saying forget about all that, use like scheduled tasks from some higher level Kubernetes thing. But all these options exist.
And on the note of Windows to Linux comparisons, for like, I know the classic delete and blow everything up in Linux is like rm-rf everything.
Yeah.
And then like in Windows it's delete system32. So do you by chance know what is in system32 and if that's related to like bootloading stuff?
Did you just ask me if I know it's in a Windows thing? How dare you?
Yes.
Do you think I have a Windows machine in this place, dude? Where do you think there's a Windows machine? No, I don't. To answer your question, I don't actually know what's in Windows System 32 folder and why it's so important. Perhaps someone in chat will have that answer, because someone in chat is like giving, in the YouTube chat, is giving the comparisons between Windows features and systemd features. So they're saying like cron tab and timers are like Windows task scheduler, systemd units are like Windows services, journal CTL is like Windows event viewer. And then I forgot one other thing that Joe mentioned earlier was you can define dependencies for systemd units using like a wanted by syntax, where you like, let's say you have a foo service and a bar service, and the foo service needs to start first before the bar service. You can configure the bar service to say it wants the foo service. So like you have a dependency order. So that's another reason why you'd want to use systemd versus like SSHing into a machine and running a process manually. Oh, good. Chat did come through. System32 folder. See, this is why I delayed for a second. The System32 folder is like the user lib folder in Linux. Perfect. So it has like all like binaries and libraries and shared object files that the machine needs to run with.
I knew it had fonts in it, and I think that's about it. I know it has very important things on there too, but I always remember like Windows doesn't let you delete things when you're using them. So whenever people delete System32, it's like, hey, you're using this font, can't delete that.
Yeah.
But ironically, not all of the other things that it needs to run. But to be fair, it does keep running usually, as far as I know. It just doesn't ever boot ever again.
Yeah, I didn't even honestly know what was in there. I know, like, I guess there's just a bunch of DLLs in there, right? DLLs, DDLs, DLLs, right? Dynamically linked library, is that what it's called? I forget. Windows things. Whereas on Linux, it's like a shared object file or something. Today I learned. See, I literally don't have a Windows machine in this entire house right now. Isn't that crazy? Like, in the entire house. Any other questions on chapter 2? So we're going to cover up to chapter 4 today. Up to and including chapter 4.
I feel like I'm pretty good at this point.
All right, let's do 3. So chapter 3, this one should be a quick one. It's basically just all about access control and like root level power, and they basically define the whole everything on Linux like has an owner, a group, and an other, and you have like, you know, your permission sets for files and blah blah blah. Did anyone have questions on this chapter?
I didn't end up getting to this chapter. I got through to chapter 2, but I'd love to hear an overview.
Yeah. File system access controls in Linux are pretty straightforward if you keep to the basics. So any file in Linux, where's that thing that I just had? Any file in Linux can have an owner, a group owner, and then like, you know, everyone else's permissions. And those permissions are like read, write, execute for the user, the owner, read, write, execute for the group owner, and read, write, execute for everybody else. And like, you know, these permissions here define whether or not read is set or write is set. So first 3 is for the owner, second 3 is for the group, and then the third 3 is for the other. So that's like permissions. So read allows you to read the file, write allows you to write the file and delete the file, and execute allows you to change into the directory if it's a directory, or execute the file if it's an executable file. And I'm pretty sure I'm correct that write gives you delete access, or does execute give you delete access? I forget which one gives you delete access, but one of them does. So that's
that would be weird if you could like, you couldn't write to the file, but you could delete it, because you could delete and create a new file with different permissions.
I'm pretty sure write is the one that gives you the ability to delete it, but I don't remember. Or execute on the directory that contains it. I forget. I actually don't remember that one. That one I'd have to look up. But either way, so
I know that about the directory though.
Yeah, cool. That's a fun one actually to show people. Execute. Like don't put execute permissions on a directory, and then you can't actually like list the contents within or whatever. You'll get denied. That's when I found out on like a Linux exam, I think. I don't remember.
Well, what a nerd.
Yeah, what a nerd. So you have these file attributes. You can own a file, right? Your user account can own a file. Your user can be part of one or more groups. Those groups can be assigned as owners to files and as well. And those are pretty much the basic permission sets, right? A user, a group, and like file permissions. That's like the basic. I don't care about anything else, just that. Then you get into like more advanced stuff. Like, do they talk about this here? I don't know if they talk about this in the book yet. I'll just quickly mention it. In addition to like that basic file system access control stuff, you have like more advanced ways of access control and whatever. You have like ACLs, so access control lists, allow you to define extra permissions on like how people can access files and whatnot. And then like some Linux distributions have like a program called like SE Linux or AppArmor that enforces other rules of how files and such can be accessed. Those are more advanced things that often I really never see anyone use ACLs in the wild often. And SE Linux and AppArmor come installed by default for the most part in Ubuntu and Red Hat style distros, but you often don't have to mess with them. And if you are messing with them and using like SE manage and all the other commands that come with it, GG, have luck. GG, have fun, good luck, all the things.
You mean specifically for files, right? Because I know I've used like network access control lists before.
Yeah, I'm specifically talking about file access control lists in that case. But things like SE Linux and AppArmor do like have rules that prevent you from like accessing sockets or doing things. So it kind of blurs the line with network access control, but it's not exactly network access control. So it's like it kind of blurs the lines a little bit.
AppArmor sounds like some weird 99-cent off-brand Android app that stops people from logging.
It really does. It's a funny name. I don't know why they didn't make that a little bit better. Like AppArmor is a weird way to describe a Linux like kind of tool like that. Anyway, so this chapter mentions like processes and process ownership. It talks about like when your user in your group, your primary group has like a user ID and a group ID. When you run programs that spawn processes, they are owned by your user ID and group ID. You can also like, there's a way to like to kind of like grant people the ability to run programs as other people, and that they call that like the effective user ID. So there's like a bunch of like little nuance here that I'm not going to get into so well. But just know that when you run processes, they have some owner, right? And usually that owner is a user owner and a group owner. I no longer sudo set enforce 0. Yeah, this is true. Me neither. I think it's enforcing on this. Yeah. I usually keep it enforcing unless something comes up. I've had to relabel some SE Linux contexts before though. Then this chapter introduces the root account. Basically, the root account on a Linux machine is the account with user ID 0. It is like the God account, so to speak. It has unrestricted access to the entire system. I'll put a little asterisk next to that because you could technically limit the root account from doing things with other ways. But generally speaking, if you have root access to a machine, you have unrestricted access to it. And that's where we get terms like, rooting the system, right? I rooted my Android phone and that's how I got access. That's what it means. Questions so far? You can interrupt me whenever, by the way.
I'm just wondering, like, I'm aware of like the concepts of like, of course, access control lists and like the file permissions, and the only times like I've interacted with it, sometimes like I'll get permission denied and to know that I may need root access to do a certain thing. And then also like if I'm installing Docker, for example, it instructs me to make this group for Docker specifically. Is it all just similar to that, like in the case that you have specific files that only a specific program should access, that you'd make a group let it access that, and then otherwise if it doesn't really matter, you just let it be? Yep,
pretty much exactly. In the Docker case, when you install Docker, usually it creates like a Docker group on your machine, and then you add your user to that Docker group, and now you have permission to like interact with the Docker files that are owned by that group. And usually the only file that you care about in that case is the Docker socket, because that's the way you interact with Docker is through its socket. So that's why you have to normally add your user to the Docker group. Otherwise, you have to run Docker commands as root because it has access to the socket, no problem.
Yeah, and then the other times I've used that is through just like whenever I'm setting up a Docker container, like you could make it so that you give like do a bunch of stuff as more root and then make a user that has like as many permissions as it needs in general.
That's also very common. A lot of people are like, that's like, principle of least privilege or whatever they call it. Only give your app and stuff permissions it needs, the least amount of privileges it needs to do its job. A lot of people are moving away from running Docker containers as root to running them as a non-root user for security reasons. So you'll see that come up. Docker also like kind of takes this whole concept and spins it on its head because it has like its own concept of users, but then it also like the host users do matter as well. It's very annoying to wrap your head around it. But that's a much more advanced use case of like permissions and root and stuff.
Okay. Yeah, then I guess I do understand more or less. I didn't know the Docker thing or like why it was done, but I knew it was there.
The Docker stuff definitely muddies the water, and I remember researching it before and I forget, but I think the Docker, like, it has its own concept of its own users, but it also does like user mapping from the host. I forget how it actually works. It'd be good to research that and kind of remember that. Podman. There's also other container runtimes like Podman that don't use like root for things. It runs more rootless. Omi asked a good question. Is the root account different from SU? So that's actually a really good question. I'm going to open my terminal real quick. So I don't actually need this anymore. So Omi asks, is like the root account different from SU? So a good question. So SU is a program that allows you to change like the effective ID of who you're going to run a command as, right? Like it allows you to change your effective ID. So if you do like SU minus, it's going to try to log you in as the root account unless you specify a different account. And here you'd have to know the root password, which I don't have a root password here. So SU allows you to essentially like run commands, as a change your user to a different like user or group. So impersonate someone, so to speak, or log in as them. Sudo, which is a similar command, this command allows you to execute a command as another user. So when you combine like the sudo and the su command, you can log in as the root user. And it's a little convoluted because these two commands are very like interrelated, right? Because sudo is like execute as a command as another user. Su is like change your effective ID to the user. So like, what are you doing? But just know that like using both these two commands have their own merit in different ways. But the general, like 99% of people are gonna just do something like this. They're gonna do sudo su minus, and that's gonna say like use sudo to run this su command as a different user. Oh, which user? The root user. Okay, now I'm running the su command as the root user. What's the minus for? The minus says to spawn a login shell, essentially. So when you run all this together, you get dropped into a root shell, assuming your user has the ability to run sudo for root. That was a mouthful. I know, I'm very sorry. But that's like the 99% use case. If you take anything away from this, sudo su minus is the proper way to drop down to the root user if you ever need to. And unless someone in chat is going to yell at me. don't yell at me. A good way to remember SU is, switch user is a good way to remember that command. Switch user.
Is sudo like just running one command as a different user? And then SU would be like you switch your ID for the session?
Correct. Pretty much exactly that. All I don't think this chapter even gets into that stuff, does it? Do we even cover sudo here? Or did I just go off on a tangent that I didn't need to go off on? Probably. Oh no, we did. Okay, yeah.
That's okay. That's why we're here.
Yeah, there's an SU part of the chapter, which like tells you what the SU command does, and then it also talks about sudo. So yeah, this is relevant to this chapter. I'm probably making some mistakes in how I'm describing some of these things, so I definitely encourage people to like read this section and make sure you understand what sudo and SU are for, and like get a better understanding of it, because I'm sure I'm not doing it the most justice with my explanation right now, especially since like I don't often think about sudo and SU. I just every now and then use it to drop down to root. I don't really like do much with it on a daily, right? It's one of those things where the majority use case is to drop down to the root user. Then there's other use cases of like running programs as other users, but like if I ever need to do that, I just reference how to do it correctly when I need to do it. Joe from YouTube comment is saying su or SU without the dash is sometimes useful if you need to debug something as root without changing like your current environment. So like it keeps the environment variables and stuff that your current user has, but then it drops you down to root. So like if you needed something from the environment, and that's true. That's a very good point to bring up. I often tell people like always use sudo su minus to drop down to root, and you'll know when you need to not use the minus. Like you'll eventually become familiar enough with what's happening that you'll know if you can drop the minus or not. Cool. All right. What else in this chapter?
I already know the equivalent to sudo in Windows is just sudo as well, so I don't even need to ask.
Do you think I knew that? You think I know Windows, dude?
But
what else?
Sudo for Windows is written in Rust, maybe even for the Rust.
Oh, true. Rust is a must. True. I didn't tell you to read the extensions to the standard access control model, so we'll skip that. But basically, like this whole standard access control model that we talked about with root and sudo and all this stuff, there's extensions that you can use to like be more powerful. There's ways to like authenticate with other systems, not just your Linux machine, right? So if you have like an Active Directory, something in your environment, you can like log in with that and blah, blah, blah. We're not going to get into all of that. Just know that exists. If you want to find out more, read chapter 3.3. And I think that was it for this chapter, right? Rust is just a must, yes. Yeah, I think that was it for this chapter. I don't remember asking you all to read anything else from chapter 3, but let me just double check. No, that was it. Oh, one thing I'll mention that I see now. You can disable the root account, so you can disable logins to the root account and prevent users from like logging in as root. That is a recommended practice on certain machines. So like you log in as a normal user and then like elevate your privileges to root rather than logging directly in as a root user. So you might see that from time to time. Just be aware that it does the thing. And Jacob, people in the chat are saying you can do like the right click run as user, or you can use the run as command in Windows.
Oh, I've never I'm still not Windows 11, so I don't know, or I've never used sudo because that's Windows 11 things, unfortunately. Yeah. And then, but yeah, I've gotten away from I don't think I've needed to use root in a long time on Windows because I use, Winget does not require me to use root, and I used Chocolatey before, and then that one did care about root access.
Oh, yeah. That
now
makes sense.
I just kind of open up, I have PowerShell always open as admin, and if I ever need to do something as admin, then I kind of know, because otherwise I'm just using my WSL Ubuntu shell.
Yeah, that makes sense. Omi's asking in the chat in Discord, would it be possible to re-enable a disabled root account? Yes, it is. There's commands that you can use to lock and unlock accounts. I think it's like some combination of user mod -L or something. I forget. I think there's a user mod command to do it. There's also another command I think you can do it. You can also do like password to set password like lockouts, change. There's a couple different ways to do it, But yes, you can re-enable a root account. Joe says, I'm doing a Kubernetes for System Admins workshop at scale in March that will dig into all the cgroups, namespace, networking stuff in Linux kernel that makes Docker and Kubernetes work. Awesome, because I will actually be at scale myself, and I'll be giving a slight talk on like Kubernetes on the Turing Pi as a home lab. So I will meet you at scale. Sweet. I didn't even know all these cool people are going to scale. That's awesome. Scale is a Linux conference in California happening like in the first week of March. For those unsure of what it is. Cool. What a small world. What a small world. All right. Chapter 4. I think this one I had you all read more of this chapter than the other chapters. I don't think I took much out of this chapter. Good.
I think chapter 2 is the most, and then chapter 4 is like in the middle there.
Yeah, that makes sense. All right, chapter 4 is all about process control. So there's like very deep rabbit holes you can go down, but just know that when you are running a process, that process has to be like represented in memory somewhere, right? So the actual process itself, like the program text has to be represented. The memory given to the process has to be represented, like the stack, the heap, all that stuff. The status of the process has to be represented. The user owners, all of these things about the process have to be represented in memory somewhere so that the computer knows how the heck do I run this process? What's it currently doing? What's next to be executed? How much resources is it using? Blah, 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 blah. All that information has to be tracked so that processes can run correctly on your machine. The kernel allows you, and it kind of goes a little bit into like what a thread kind of is in this case. Every process has a single thread, but some processes can have multiple threads. We call processes that are running on multiple threads multi-threaded processing, or multi-threaded processes. And I think that's all I wanted to cover in that part. Cool. When you have a process, a running process, well, I'm petting my dog right now and he's so soft. I'm sorry. So if you see my arm moving off to the side, it's because he's so soft. When you have a process, the kernel assigns a process ID number, and then you can do things with that process ID number to send signals to the process, get more information about the process, and blah 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 blah. And Linux also now has this concept of namespaces to further restrict processes and whatnot. Namespaces are kind of like the bedrock of how containers like Docker and stuff are built upon. And you're going to have to attend Joe's Scale Talk to learn more about it. Cool. Any questions so far? Sorry, I know there's a little bit of a monologue. Hey, Blake, what's up, man? I don't think so. Good stuff. Sweet. Okay, this is a good section to read. This right here, this PPID parent ID. This right here took me a minute to get my head wrapped around when I first understood it, but I'll just repeat it for those watching. Linux and Unix doesn't have a way to initiate a new process, essentially, right? There's a two-step process. Sorry, there's a two-step method that's used to run a new process. You have to first clone your process and then exec into new process. And this thing is called the fork exec model, right? So, for example, you have a process that's running. Call it your systemd init process, right? PID number 1. A new process needs to start, but it can't just start a new process out of the blue. So what happens? The PID number 1, it forks itself. So now there's a clone of that process. So clone of memory, clone of all this stuff. Then that new clone wants to go off and do its own thing. So what it does is it replaces itself with an exec call. So it replaces its process by calling exec. This model is called, like I said before, the fork exec model. Definitely, I would encourage people to research up on that a little bit more because it is a very interesting design, and pretty much all Unix and Linux work with this design. and I'll answer questions about it if anyone has questions so far. Now I'm in the cool kids chat. Oh, you joined. You're in 2 places, Jacob. You're 2 places. Okay.
I was in the Twitch one too.
Nice.
There's no one in there. But now I can see all the people who are helping you learn all the Windows stuff that I had.
Yeah, we got a good amount on YouTube.
To be fair, I do not research any of this stuff. I'm just like, wow, these file permissions are frustrating. I'm leaving.
Yeah.
And using Linux versus but yeah, now that I know Run as exists, I will have a much better time whenever I need that.
Joe says PS3 is nice to visualize all of these child processes and process trees stuff, which is actually really nice. This is cool. I always forget about this command. Okay, so this chapter also goes into a little bit more detail about that UID process owner and effective user ID, and it basically says the UID and effective user ID are a good way to split up identity and permission. So if a process is owned by a UID, that's the user that is the identity for the process owner, and the effective user ID is the user ID that is given permissions to this process, right? That process runs with that user ID's permissions. I thought that was a pretty succinct and nice way to say that, because I remember when I first read about effective user IDs, I was like, well, huh? What does that mean? So it's nice to see that. And the same process happens for group IDs and effective group IDs. Did they cover the fork up here? I forget where they covered that. Clone. Yep. I think it covers it more. Oh yeah, it covers it here. Okay, we'll get to it. Perfect. We'll talk real quick about niceness and control terminals since it's here. Way back in the day, CPUs were much slower than they are today. So if all of us in chat right now wrote programs to run on the same computer, the CPU was pretty slow, and if one of us was taking too long running doing something in our program, we can hog CPU time. So niceness was a thing that you can change the niceness value of your process and basically say, I need more or less CPU time, and that allowed the kernel to schedule your processes a little bit better and give a more fair CPU time to the processes. Nowadays, CPUs are extremely fast, and oftentimes you'll never even hear about niceness, and you probably never have heard about niceness in your life, nor will you ever have to touch it, but it was a thing. Control terminal is a good thing, and I think we'll talk about this more in a later chapter, right? It says see page 190, but when you run a process, there is such a control terminal attached to the process. That's how you can type input to your process and give it signals like control C or whatever. That is just done via a control terminal. And I'm actually excited to learn more about that stuff when we get to it in 190, in some future section. Cool. The Windows equivalent is CPU priority, as seen in Task Manager. Perfect. What a name. Yeah, it is a name. Let's talk about the life cycle of a process, because I think this is a pretty fun one. So we said before, if a process wants to create a new process, right, it copies itself with fork. So that copies the process, and it's pretty much an identical copy of the parent. The only distinction is that the process has a new process ID, and it has its own metadata and such. Now, when you are writing a program and you make the fork system call, right? If you call fork to do a process clone, it's funny because the child process that is cloned gets a PID of what its PID is, and the parent process that was cloned from gets the return value of 0. So in your program, you'll often see result equals fork. If result equals 0, I am a child. Or sorry, I am a parent. If result not equals 0, I am a child. Let me go off and do my child things and call exec to swap out my process for a different process. I hope I explained that pretty well, but this was a very nifty thing to read about and see. I even read about it in the Linux programming interface book that's somewhere back there. But processes don't just like spawn out of nowhere. They have to come from like some other process. They clone themselves, kind of like, cells, how cells clone themselves, and then they go off and do their own thing. So any questions there?
Rest async book too.
Oh, this was in the Rest async book, right? Yeah, I remember that.
Yeah.
Oh, this is that book.
Cool to see how the APIs were different because they work different.
Yeah.
In Windows versus Linux, that is.
Boom, that book. Yeah, this is true. It's true how the APIs do work differently across operating systems. Okay, that's all I really want to cover from that lifecycle part. The rest of this, like the rest of these paragraphs, basically just say like the very first process that starts on your machine, the init process. It starts up as PID number 1, and then it like fork execs, and then eventually you have all these processes running on your machine. Cool. What else? Oh, Jacob got pulled into work again. Cool. There's not much else to go in, so I'll run through this last section of chapter 4 pretty quickly. So let's talk about signals. Hello, everyone. Hey, what's up, man? When you're running a process, if you want to send that process like interrupts, you send them signals. There's many different signals you can send a process. You can send them signals via the control terminal, right? So if you're running a process in your terminal, you can just send like control C, control Z, whatever. Or you can use the kill command to send a specific signal to a specific process. And the book details like all the different signals that every administrator should know. To be honest with you, when I looked at this, I knew sig hup, sig int, sig quit, sig kill, sig term, sig stop, and sig continue. I didn't know of the rest of them off the top of my head. So it was good to see some of these signals. If you are writing a program, like if you're someone writing processes and programs, you can catch these signals and handle them and do different things. This is very common, like in Go or some other language that you're writing, where if you want to like have the user, if you want to respond to when a user types control C, you write a handler for that. And you say, I want to catch, sig ints. And I want to do something when sig int is given to me. And I want to cleanly shut down my program before going out. So there are certain signals that can't be caught. And I think that's just sig kill and sig stop. And that's all I really wanted to talk about with signals. I didn't want to get into all the nuanced detail here. You can read that if you want on your own time. But that's all I want to show you. I used to have a license plate that says sig term. I've been thinking about getting a custom license plate that's something like that. I was thinking about getting a license plate that says sudo mv, like sudo move, because I think that will fit on the NJ license plates. Yeah, that's 7 characters. So we'll see. I just don't know how much nerd I want to scream out for my license plate yet, I'm not above it. I just don't know what level of nerd I want to scream out. This is my life. And my wife's probably going to look at me like, you're a nerd. This part of the book just talks about the kill command. That's how you can send a process a certain signal. Pretty self-explanatory here. Read the man pages, read the help pages. Nothing much here. Nothing much there. Process and thread states. I'm not going to talk so much about this. You can all read this, but basically, like, the kernel organizes its running processes on threads. Threads can enter different states. They can be runnable, they can be waiting, blah, blah, blah. And the kernel basically is responsible for managing, like, the states of those threads and swapping them in and out on the CPU. Sending a signal to get a status dump or force a configure load is still pretty common. Yeah, I've seen that actually. Cockroach does that. Cockroach database, if you send it sig hup, no. There was a signal that you could send Cockroach and it would do a CPU profile dump. And like you could just go get the dumps on disk or whatever and then like see what's going on. We used to do that all the time. Like when I was back working at Cockroach, when there was like a error with Cockroach DB or whatever, we'd go to the Kubernetes node, go to the node, get a debug container in there, and then like send it a signal. I think it was sig hub. No, it was something. I forget what signal it was, but we would send it and it was configured to listen for that. Actually, it was probably sig user or something. I don't remember. One of the most, and I'm checking the chat. Omi, if you're chatting in, okay, no, I think you joined stream chat too. Perfect, even better. If you want to monitor processes, you can with the PS command. The PS command is one way to see the processes that are running. So if I went to my machine and I type PS, I can see the processes running from my current session. If I want to see more, I can do like PSEF or PSAUX or various different options, and I can see all the processes that are running on my machine. And then I can do things with those processes because now I have information about them. I can send them signals, I can whatever. So PS is a very good utility to monitor processes. You should play around with PS and learn it. To be honest with you, I still don't know all of the different ways I can use PS. Most of the times I just do like PSEF grep or PSAUX grep. I don't like fully know all of the process, the PS like flags. I probably should, but maybe one day. Maybe one day. Outside of PS, you can also monitor processes and such with top. Top is a fun command. If you run top, it'll show you a listing of all your processes, and this is a live reloading thing. Every, I think, 5 or 10 seconds, it'll reload and like show you updated stats about the processes. You can type different commands in here, like capital P will sort the processes by CPU percentage, and you can see that OBS is using most of my CPU right now, as is GNOME Shell, as is Firefox, and more Firefox. If you want to see more things like the total number of cores and usage, you can hit 1, and you can like go see core specific stats. You'll see that I have 16, this is technically threads. I have an 8-core machine that can hyperthread to 16 cores. And you see that like most of the cores are actually idle here. They're not doing much. So I can just see all this information about my machine and monitor my machine. There's also like other variants of top. There's H top, B top, whatever top you want to use that give you similar information. Nice and re-nice. We don't need to talk about that like in detail. We already talked about how nice, if you mark a process's niceness like lower or higher, it's basically saying I don't want to use the CPU as much, or I do want to use the CPU more, and it influences how processes get CPU time. The lower a niceness score means you're not nice, means you want to hog the CPU, and a higher niceness score means you're nice and you don't want to hog the CPU. And that's really all I'll say about that. I don't think I've ever had someone run this in a live scenario before, or nor have I ever had to run it outside of like a Linux exam cert test or something. Tell me which PS flag does this thing is a favorite type of system interview question with people who are bad interviewers. Yeah. That's so true. If like legit though, Joe, if I went into an interview and they were like, tell me what this PS flag does, I'd look at them and be like, you're kidding, right? Because are we talking GNU PS? Are we talking BSD PS? Like what are we talking about here? I would just be like, you know what? I'm out. See you later, man. I'm done. Oh, and Anna on Twitch says, welcome back. Thanks, Anna. Thank you. I still have to do the assets that you sent me, but I have been busy. I have them. I just haven't uploaded them anywhere. I think there's 3 more things I want to talk about before we'll end, and that will be the proc file system, strace, and cron. So let's cover those. So out of all of the ways you can manage and monitor processes, the one way is via the proc file system. PS, I'm out, boy. The proc file system is /proc in your machine. So if you like ls/proc, you'll see a bunch of stuff in here, and you can like go throughout this file system and like get information about different processes. Now, this isn't actually a real file system. It's called a pseudo file system, meaning when you like read a file from that file system, the kernel will just respond with like state from its memory, right? So there's no actual file on disk anywhere. It's just a virtual file system. And that actually took me a long time to wrap my head around too when I first learned Linux. I was like, what do you mean it's a virtual file system? I see the files right there. But you don't. It's just really like a kernel provided thing. I'm not going to go into the specifics around proc, but what I would say is there are many, many different subdirectories in proc, and the numbered directories here are the process identifiers. So I will just show you one thing. So when I did PS before, you see that I have this 62484 process ID. If I did ls/proc 62484, this is all the information about the fish process that I'm running. I could do something like this. I can cat out the command line for it. And you can see this is the full command that was run for this process. And there's null terminated stuff in here. So like it looks like it's all one line, but it's not. There's like null characters in here. But I can cat out the full command that's been running. I can cat out the environment variables, which I'm not going to do because that might expose some things that are sensitive. I can see how much memory the process is using or the file descriptors that it has open and blah, blah, blah. Very, very powerful stuff. When I did the sad servers challenges stuff the other day or last couple months ago, there were some challenges there that like had you go into the proc file system to find out information. I very much encourage you to do a read-only poke of your proc file system and just see what's in there. There's some cool stuff in there. And that's all I want to say about that. strace. I've actually never used truss, so I don't really know how truss works, but strace is a way to do, I think it's called what? Is it called system trace? Is it called service trace? I don't remember what the S stands for. Should have piped that to less. I don't remember what the S stands for. I think it's service trace, system trace. I don't even remember. But strace is a way for you to see what the heck your processes are even doing. So if you run strace with a process, so if I did like, do I still have that log file here? No, I don't. Let's do echo hello to hello.txt. And if I do like cat hello, I'm echoing it out. If I put an strace in front of that, you will see all of the system calls that get executed to do this cat hello text, right? You'll see that like it does a bunch of memory map. At first it does like an exec VE, so it can like do its process running. It does a bunch of memory mapping, whatever it does here. Eventually it's going to open a file, or did I look at the wrong call? No, I think I looked at the wrong call. Yeah, right here. It's going to open the file. It's going to stat it. It's going to do all this other stuff. It's going to read the file. It's going to write the results to your standard out, and then it's going to close everything, all the file descriptors. So like this is literally a system call trace of what's happening when you're running programs. Super, super useful. Really nice. What I didn't know until today, and I feel very embarrassed admitting this on stream, I had no idea until I read this stupid chapter in this book that you can attach to a running process with strace. I had no idea you can do that. I thought you had to strace and run the process from scratch. I didn't know you could attach to a process. I feel stupid. It's okay. You could here's my Linux card. Have fun. I'm so sorry, but I had no idea that you can attach to a process with strace. This would have made my life so much easier in times where I use strace. I just feel like I'm sorry to my past self that had to like do things more difficult than I could have. So past self, I'm so sorry. But yeah, you can use Ash. Yeah, hand it over. Yeah, please take it. I'm sorry. Just I'm not worthy. I'm not worthy. And that's, I think, all I want to show about strace. It's a good way to see the system calls that are being ran via the process. Joe says, I've had to strace things because they have terrible error output and would just die right away with a generic error like file not found exiting. Which file? Got to strace to find out. Yeah, I had to do that. And that was another thing in the sad server challenges that I did last time, like a couple months ago or whatever, is finding files for like the secret password files or whatever. You know, the program would open up a file and I have no idea which file it's opening, and I use strace to see what file, and then you like put something in that file and do something. But yeah, it's a very useful tool. At work, a lot of people at work use something called dtrace instead of strace. And I wouldn't say instead of strace, it's more of like a different way of tracing programs. But that's because at work we do a lot of like Lumos work, which is a slightly different Unix style system. And we don't really use strace, we use dtrace. But there's many ways to do this, right? strace, truss, dtrace. There's many ways to get information about running processes. and they all have their pros and cons, and they all, you know, work on various different flavors of Linux and Unix and whatever. So you should try it on your stuff. I mean, I just showed you a very trivial example of like stracing a cat hello.txt, but maybe you want to write a small hello world Go program or Rust program or whatever, and then strace that and see exactly what it's doing. Could be fun to learn. Runaway processes we don't really have to talk about. It's just, you know, if your program is incorrect, it can have a memory leak, it can have like a CPU hog or whatever. You're going to use some of these tools to figure out what's happening and try to nail down which process is the rogue one. And that's all I want to talk about there. And the last thing in this chapter that we will discuss is periodic processes. If you want to run something on a schedule, right? Like I want to run something every 30 minutes or every 5 minutes, you can use something called cron. Cron is just a like chronological daemon, right? It runs things in chronological order or at some sort of cron time. And you can use that to run different processes. You can do crons at the system level or at the user level, up to you. I'm not going to go into so much detail. You can spend like 5 minutes and figure out how to use cron on your own time. If you don't like cron for whatever reason, there's a systemd has its own version of cron called systemd timers. So systemd timers allow you to like write a systemd unit file that runs on a specified time. Same thing as cron, but with all the power of systemd instead of just like, you know, run program with arguments. You have more power with systemd. I haven't really used systemd timers because like right around the time they were kind of released and going, you know, and cron was going out of style and systemd timers were coming on the market, containers just got so much more popular, and there was like other ways to run programs at a like on a schedule, right? Like Kubernetes jobs comes to mind, and people just use that. And yeah, okay. I think that's it for all the reading. For those that weren't here when I started, we're kind of doing a speed read of this book. So my friends and I, that like some of the friends in here that were here asking questions, they want to learn more about Linux, and they wanted to like read this book because it's a good book. So I like filtered out the table of contents for them and said, here's the sections you should read and here's the sections you should skip. And we're basically going to do, I think, 4 sessions, maybe. Yeah, I think we're going to do 4 sessions to try to read this book in a month, or speed read it in a month. So this was session 1. Does anyone have questions? I think we're going to try to do it in a month. Or we're going to read half the book in a month, I think is what the idea is for now. Yeah, I think that's the idea. Anyone have any questions before we call it? Man, Restream is interesting. It's like my preview is so like bad, but I look at it on Twitch or on YouTube and it's so good. I think, let me see what's coming up next while I give anyone a chance to type questions. What's next for us? I think next is gonna be. Oh, we don't have the next layout yet. Okay, I think Jacob has to make the outline for that. Cool. Probably gonna be like another 3 or 4 chapters, so it shouldn't be too bad. Thanks, Mateo. You're welcome, Johnny. No questions from me yet. Thank you. You're welcome, Omi. Yeah, if you have any other questions, I mean, this is good. I was gonna do this book club with you all anyway, privately, but I figured I'll stream it and just put it on the channel, and that way it just helps people, you know. Sometimes just talking about these things, even if you're not like perfectly correct with how everything works, is just nice to help explain it to people. And, you know, I learned something too, right? Like you all taught me a bunch of stuff about Windows and about Journal D and all this stuff. So that's why I like to get up here and stream some stuff and talk about it, because I don't mind looking like a fool if I need to sometimes, right? Like I don't know everything. That's why I talk about it. Cool. Well, if there are no questions, comments, or concerns, then that'll be all. I will see you all. I think we're going to do this every Thursday at 5 p.m. for the next maybe 4 Thursdays or so. But it'll be on the YouTube channel. I'll put the scheduled streams on the YouTube channel, and I'll announce it on social media so you can all follow along. And if there's things that come up after the stream, just reach out and we'll talk about it. I need to go make dinner for myself and my wife because, I didn't realize we were going to go almost 2 hours, but such is life. And now my dogs are looking at me like I'm crazy. All right, everyone. I'll see you soon. And there'll be more programming streams for me too. I'm going to start working on some open source stuff at Oxide that I can stream. So I'll be doing that too. But all right. Bye, everyone.